My project is about the face recognition. First, let me introduce about the procedure of the face recognition. The complicated face recognition have 4 steps. The first step is face detection. In here, it shows as the face and leg localization. Then, after we localize our face, we can do the face normalization, which is to align the face. And after the face was aligned, we can do the feature extraction. And select the feature, we need to do the feature matching. That's the 4th step here. And my focus is on the feature extraction and the feature matching. Let me introduce the present situation of the face recognition. Face recognition is very popular and is widely used in different fields like the security, pavement, and there has already have many techniques of face recognition, like user principal component analysis, linear discriminant analysis, and convolutional neural network. And the convolutional neural network is the most popular one, and my implementation is based on this. There are a lot of difficulty when we need to face in implementing face recognition. The changes of light and the changes of the human emotion or the gesture will affect the feature detection and the feature extraction. So a complete and delicate design of the face recognition will need some complicated algorithm to avoid this difficulty or to overcome this difficulty. First, let me introduce the convolutional neural network. The CNN consists of several convolutional layers and a deeply connected layer and an output layer. The convolutional layer is the most important part in CNN, and the ability of the CNN to discriminate feature is greatly dependent on the design of the convolutional kernel, and the convolutional kernel is defined in the convolutional layer. Then we need a pooling layer to use to reduce the dimension of the input information. The pooling layer can be defined in the CNN as a separate layer, or it can be embedded into the convolutional layer. The fully connected layer is used to connecting the neuron from the last layer to the next layer, and the output layer is used for output the results. Then I want to describe some latest development. The first one is DeepID. DeepID already have 3 generations, and here I only introduced the first generation. The first generation of DeepID is using a one-to-one relationship between task and target. And the point of this method is it uses a very large data set to train the model. The structure of the DeepID is at the figure. It has 4 convolutional layers, and the pooling layers is used the mass pooling design, which will output the maximum to as the output. And the first generation of the DeepID can already attain an accuracy of the 97.45% on the LFW, the label facing a wild dataset. And when the dataset for training is larger, the accuracy of the face verification of the DeepID will be higher too. Then I want to introduce the FaceNet. The FaceNet it's different from the DeepID because it removed the soft mask layer and used a novel online triplet mining method to train the data model. So the selection of the triplet can lead to a different speed of computation. The FaceNet directly mapped the face images to the complex Euclidean space. It used a deep convolutional network chain to directly optimize the mapping. And the performance of the FaceNet is really excellent because it broke a new record on the LFW. It achieved the accuracy of 99.69 on the LFW, and it got the 95.12% accuracy on the U2 face database. And it controlled the error rate under 30% on both datasets. Here I want to evaluate the existing approaches. I only compare the first generation of DeepID and another kind of method use the soft mask layer as a component of the CNN, which caused a large migraine soft mask loss, and compare with the FaceNet, which is developed by the Google. And the FaceNet can achieve the highest accuracy on LFW, and their algorithms is all based on CNN and all make some changes to the standard CNN structure. Here I want to implement my demo. First, we open the terminal. And run the train file here. The training dataset is include more than 1,000 images from the LFW dataset. And our target image only have 9 images to reduce the computation. And we have 2 images for test. The ABC point JPG is the target face we need to find and track, and EFG line JPG image is not the target we want to. Because we changed the test Python to a fake fake. The training is finished here, so we need to do the task. No. Is the target is false? Yeah, it's false because the import images is not the target, and then we change the for target. It says the target is true. Yeah, this is true because this is our target. So let me back to our presentation PPT. And this is the accuracy curve I got from TensorBoard. It can show that at first the curve is not so high and it have a turning point here. So we can know that but after enough time the accuracy can achieve above 0.95, which is 95%. So we can know that after enough times the data model got trained, the accuracy of the data model can got an accuracy above the 95%. And this is the loose curves I got from calculation, the visualization of my model. And we can see that the loose is going lower and lower as the time of the model got trained. It's growing. So I can conclude that the CNN training for the data model is useful and productive. But since my implementation is very simplified version, so it will have some errors, but it's acceptable. My conclusion is the DeepID and the FaceNet and the large margin software loose method is all a very excellent method to do the face recognition. It can both achieve the 95% accuracy. And my implementation is based on CNN structure. But since my implementation, it can only recognize the front face of human beings, so it is the shortcoming here. Thank you for your listening for my presentation.